Okay, welcome to chapter 4 here. We got some trigonometry here we're going to get into. Beginning with discussion and radian and degree measures. And you guys are pretty familiar with degrees, so we'll start with that concept. Here we have what we're going to refer to as standard position of an angle. This is an angle drawn here. This is the x-axis, this is the y-axis, this is the vertex. So standard position, when we talk about standard position of an angle, what that's going to mean is the vertex is located at the origin. The initial side is on the x-axis. That does not move. Now the terminal side, that's where the angle stops. And this can go anywhere on this picture here. So this is a 0-degree angle. It's not open at all. Right about here would be like a 30-degree angle. Here would be about a 45-degree angle. Here would be like a 60. And then hopefully you realize that this up here would be 90. And I can keep on going over here. I would see, okay, here's 135, say for instance. Here's 180. Here's 270, and then here is 360. Those are positive angles because I'm going this way. I could have done the same angles by going this way. These are called negative angles. So this angle here, for instance, could be called negative 90, or it could be referred to as positive 270. That's what coterminal angles mean. I could add basically anywhere that I stop, if I just add or subtract 360 or any multiple of 360, I'm going to land back at the same spot, resulting in an angle that looks exactly the same, even though it may represent having gone around 2, 3, 4, or however many times. It ends at the same spot. It looks like the same angle. We call those coterminal angles. And once again, you can figure out coterminal angles by adding or subtracting 360 to whatever it is that you get, or any multiple of 360. A radian is another way of measuring an angle. We've talked about degrees, and some of you have experience with radians a little bit, but we're going to have to start really using radians here a lot. So what a radian is, if I say, all right, here's the radius of the circle, imagine that this is a string, and I cut that string and I start wrapping it around the circle, and it sticks to the circle. Eventually I'm going to run out of string. This arc length is going to be the radius. Well, the angle that gets formed between where that string ends, and I draw that to the center of the circle, this angle formed is 1 radian, which we abbreviate RAD. That's the definition of a radian. There are approximately 6.28 of these things around an entire circle. Every angle can be written as a degree measure or a radian measure, and so here's a simple method for changing between the two. If I give you an angle in degrees and I ask you to convert those to radians, all you're going to do is you're going to multiply by the fraction pi over 180. So for instance, for 30 degrees, I'm going to take 30 times pi over 180. This is like reducing the fraction 30 over 180 and leaving pi alone. Well, 30 over 180, 30 goes into 180 6 times. So I'm going to call this pi over 6 radians. Do the same thing, pause and revisit us here and attempt these, but 45 times pi over 180, because 45 goes into 180 4 times, this is equal to pi over 4 radians. And 60 degrees can be multiplied times pi over 180 also. 60 times pi over 180. 60 goes into 183 times. So this is going to be pi over 3 radians. So going the other direction, if we start with radian, or degrees rather, no, we start with radians and we want to convert back to degrees. So I told you you have pi over 6 radians. So if I have pi over 6, and I want to change that radian measure into degrees, I'm going to multiply by the reciprocal. Instead of pi over 180, it's going to be 180 over pi. Well, the pi's are going to cancel. I have 180 divided by 6, which gives me 30 degrees. You can see from above that is correct. I'm supposed to get 30 degrees. I do the same thing for pi over 4. I take pi over 4 times 180 over pi. Pi's cancel. I get 180 divided by 4. That is 45 degrees. Okay, so hopefully the sound is still good. I had to give up the tablet here and go to the smartboard. It was being slow with me. I don't understand why that was. So continuing on here, for 60 degrees, which is pi over 3 radians, I can take pi over 3, and I can multiply it times 180 over pi, and the pi's will cancel. I get 180 divided by 3. That is 60 degrees. So that's how I go from radians to degrees, or on the top up here, I've showed you how to go from degrees to radians. Now on this slide here, I'm highlighting over on the right here these special right triangles here that you're gonna want to make sure that you are fresh on these. You might not have seen them in a while, but what we will eventually do, not today, but we're going to superimpose these on this circle with the point here. So we'll draw a 45, 45, 90 triangle right here. And we're going to be able to do, for instance, sine, cosine, or tangent of 45 degrees. And we could put it over here to do 135 degrees, or we could put it over here to do 210, or over here to do 315. So we could do the same thing with the 30, 60, 90. So we'll get to it later, but for now, make sure you refresh yourself on those if you're not at all familiar with them, or if you've forgotten about those. So what I have here, if we were to start in standard position, as we said before, with the vertex at the origin, the initial side staying put here, and I opened upwards, I have a 30, a 60, 45 I stopped at here. On the top, I forgot to write it, but this would be 90 degrees. Moving all the way over here, 180. Down here at the bottom, 270 degrees. And all the way around, 360 degrees. And I've got a bunch of angles here drawn in also that I'll demonstrate are accurate by putting this on here like that. And you can see, if I can get this to shrink a little bit, those are in fact the angles that I'm claiming that they are. And I can spin this around down here and show you that those are accurate as well. Okay, so you see that. We'll get rid of this. Now what we're going to do on this is we're going to write the radian equivalent for each of these degree angles. And all of this, the way I do it, is I remember that pi radians equals 180 degrees. If you can remember that, you can figure everything else out here. So for instance, we start here. There's pi. You know what, I'll do this instead. So we keep the colors. It stands out a little bit more. So the red colors are going to be radians. Red equals radians. Well, if that's pi, 90 up here on the top is half of 180. So this is going to be pi over 2. So now what I'm going to do is I'm going to count by 90 degrees. If I go 90 degrees once, 90 degrees twice, 90 degrees 3 times, 90 degrees 4 times, I can represent those in terms of pi over 2. So let's count. 1 pi over 2, 2 pi over 2, that reduces to pi. Down here is going to be 3 pi over 2. And then all the way around is going to be 4 pi over 2, but that reduces to 2 pi, which should make sense because that's 2 of these 180 degrees. That's 1 pi, here's 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, and so on. Now, if pi over 2 is 90, and I know that 45 is half of 90, I'm going to take half of pi over 2, and I'm going to get pi over 4. Now I'm going to count by pi over 4. So I'm going to get all the 45-degree intervals around the circle. Here's 1 pi over 4, 2 pi over 4. I've already got that one. Here's 3 pi over 4. We got 4 pi over 4, but that's already good. 5 pi over 4 down here. We got 6 pi over 4, that's already reduced. Over here I've got 7 pi over 4. and then 8 pi over 4, but that's already taken care of. Now I'll go to the 30-degree angles. Well, 30 goes into 186 times. So 180 divided by 6 is 30. So pi divided by 6 is pi over 6. That's the radian equivalent of 30 degrees. So that's 30, 60, 90. We're going to go around the circle and fill in all the rest, and we're going to count by pi over 6. So here's pi over 6. Here's 2 pi over 6, but we got to reduce that. 2 pi over 6 becomes pi over 3. We got 3 pi over 6 already. Here's 4 pi over 6, but if you think about 4 pi over 6, that's 2 pi over 3. Okay. 5 pi over 6 is right here. And then I've got 6 pi over 6 already reduced and taken care of. Down here is 7 pi over 6. Here's 8 pi over 6, but that reduces. 4 pi over 3. Here's 9 pi over 6. That's already taken care of. 10 pi over 6, which is 5 pi over 3. And then here's 11 pi over 6. And finally, back all the way around is 12 pi over 6, but that's already reduced. We have to become very comfortable and familiar with these fraction forms. Some things are just easier to do with radian measures as opposed to degrees. I don't advise you go off of memory. I really advise that we operate with the understanding that pi is 180 and everything else can be figured out from that. It's the way I've done it in my head for years. We'll end this video with this here. How long is the arc on each circle? Well, what I used to tell my classes when I was teaching geometry was to take the angle, and I'm talking here about this arc right here. I have a 215-degree angle out of a possible 360. Well, if I multiply that times the circumference of the circle, which is pi times diameter, which is 8 pi in this case, I can type this in, and I will get the length of that arc. So in my calculator here, 215 in parentheses divided by 360, and I take that answer times 8 pi, I get approximately 15.01. That would be centimeters. That's the length of that arc. And that was fine, but now we've got radians, and it's a little different. So you'll notice here, when I do this one in radians, if I do that same thing, I have 2 pi over 3 out of 360, but I can't call it 360. I got to call it 2 pi. I'm going to call it 2 pi over 1. I'm going to take that angle, that fraction, that's just like the fraction here, and I'm going to multiply that by the circumference of this circle, which is 12 pi. If we simplify this, we know that when we divide by fractions, we're really multiplying by the reciprocal. So this becomes 1 over 2 pi. Well, the 2 pi's cancel each other out. I'm going to multiply that by 12 pi. So what's going to happen here is I have 1/3 of 12 pi, which is 4 pi. And that was inches. That's the length of this arc. Now I want to point out that that could have been found by just multiplying the angle in radians times the radius. That's our shortcut for how to find arc length when we're dealing with radians. So had I done 2 pi over 3, the radian measure, times 6. 3 goes into 6 2 times. 2 times 2 is 4. I would have gone directly to my arc length. That's how you're going to want to do that. We're going to end this video. We will resume in the next one.